Hello, good evening, everybody. Okay, so thanks for the waiting. So in the beginning of the this live stream, I already see quite a few comments on the screen right now, which is I'm quite glad because all of you are waiting for it. And hopefully in future, if we have time, I'll be able to do one by one. So today, I would like to dedicate my sincere acknowledgement to StreamYard, okay, for giving me this very nice this live stream view because through this StreamYard, I'm able to show you uh, all the these comments down there. If you can see the comments down there, that means the StreamYard is doing its works for now. So that is why I feel so thankful. And using these comment sections, I'm able to show you on what are the questions that you can see from here. Okay, so one of the disadvantages is I need to click on my own, but it doesn't matter as long as you all are going to see it, and then for me it's fine. Okay, so without any hesitation, let's begin. So a very good afternoon to everybody. I'm Mr. Chu, well known as Chu Sensei. So hope that you have already taken your lunch and are ready for our upcoming live stream view. And if you have any questions, just comment on the section below and I will highlight the sections and then uh, I'll be able to answer straight away towards your towards your comment. And don't feel shy. If you have any things that you cannot understand, just feel free to give a comment. Okay, so I will try my best to answer all your questions if you are able to, if you are ready for this. Okay, so I hope that you all are able to see my video for now. Okay, so can you all see that? Okay. Okay, so without any hesitation, let's begin our lesson, shall we? Okay, so let's begin. Okay, so for the introduction, so I'm going to temporarily close my face for a while so that you can focus more on the slide. Okay, so I'm going to remove. Can you all hear me now? I'm so sorry. I'm also not sure what is going on. I apologize. How? Wait, sorry, sorry. I try my best. Okay, can you all hear me now? Okay, can I? Okay, sorry. Okay, probably I need to use this. Okay, so I think because I this unmute this, so so if I disable. That means I have to turn on this. So sorry. So you have to see my face throughout the session. I have to enable the screen right now. Only then I'll be able to hear. Okay, so never mind. Yeah, because it seems that I need to do this. Okay, so. Okay, so here is my achievements. So I used to be a national trainer for chemistry STPM syllabus. Thank you very much. No, okay. So I used to train national trainer for STPM syllabus, and then I'm also used to be a STPM examiner for section B and C from year 2012 until 2017, and then I was also a national moderator for school-based assessments from 2013 to 2017. I'm also a motivator and lecturer giving talks about STPM chemistry and technique of how to answer in nationwide. I've been doing this since 2008. So. And then for now, I'm now focusing more on my, because now I'm more active in sports events. So I'm now go towards coaching for triathlon event. I'm still building up my reputations for coaching triathlon. So anybody, if you are interested in triathlon, then you just let me know. Okay. Okay. So I also own my blogspots. Okay, at www.chemistrychill.blogspot.com. Okay, and then also you own this YouTube channel, which is Chill Sensei. Okay, so I'm glad that throughout this way I'm able to communicate with all of you. Okay, so now let's go to the main focus for today. So today we are going to discuss for STPM Semester 2 2021. I'm not sure what is the style is going out, but I'm hope that from today's talk you'll be able to benefit from it. Okay. Okay. So okay, so here are the base assessments. So you have already gone through semester 1, so which is the 60% of your content. Okay, so semester 2 and semester 3 also goes in the same way, where you have a written test in 3 sections: section A, section B, and section C. Section A is made of 15 compulsory multiple choice questions, while section B is made from 2 compulsory structure questions to be answered, whereas section C is 2 questions to be answered out of the 3 essay questions. So now, given duration time is 1.5 hours, that means 90 minutes, you must be very good in your time management in here. Whereas I'm hoping that you'll be able to manage your time well, so that you'll be able to get 90 minutes exactly. So my suggestion is, since the distribution of section A, section B, and section C, so section C, 1 essay 15 mark, 2 essay 30 mark, So the time distribution for section A, B, C, the two essays here should be equal. So I would suggest you all to solve 20 minutes for section A, 20 minutes for section B, 25 minutes for each essay of section C, and that will be nicely made to 90 minutes, okay, of your whole STPM examinations time given, okay. And then don't forget, you also have the 90% of this, 20% of this school-based assessment. So hopefully you'll be able to use your time, use your school-based assessment well. Okay. Okay. So hopefully you all will be able to gain from it. Okay. Okay. So now a little bit of studying tips before examinations. Okay. So before examinations, so make sure that you have read in details of all chapters of STPM Chemistry. If possible, make your own short note based on your understanding and check with your teacher reference book or any online sources. You also should do all the past year questions available. So not 5 years, typing error, should be 7 years back. You have new syllabus from 2013 until right now, 2020. You are 2021 students. So you have altogether 14 sets of the STPM. So when you have 14 sets of STPM, you should try your best to solve all of them, okay? And answer I've already shared with your teachers. Your teachers will share the answers with you about objective structures and essays, okay? So you'll be able to get response to your answer well. And then last but not least, if possible, do a study group with your friends. A group study is always the best way to study in STPM STPM. You hardly survive if you study alone, as the school or STPM are too wide to cover, unless you're really very good students. I know that some of you are very good students. You can study on your own. But if you are good students, do try to help those who are weak. Actually, from my experience, this is what I built up. We as a teacher, we have experience because we keep on teaching the same thing. So if your friend don't know, you might want to share your knowledge with them, so that not only that you teach them, actually at the same time you learn yourself. Okay, so teaching is always the best way to remember facts well. Okay, so that is why you'll be able to this one. So if it is MCO, let's say some of you say, teacher, because of MCO, okay, so I'm not be able to meet up with my friends. Nowadays, technology, come on, okay? You can have FaceTime, you can have WhatsApp video call, even Telegram nowadays can also have video calls, okay? So just do to your very best, okay? You have to adapt with the situations, all right? Okay, so MCO shouldn't be an excuse for you not to study, especially next month is already STPM Semester 2, and I believe most of the states will be resuming your lesson on 3rd October and 10th October respectively, okay? Okay, so that is for the introductions. So we are going to go to our main focus for today. So our main focus for today is to discuss the STPM 2021 trial examination question from my school. I've already said for you, you can always download from my blogspot together with the answer. The answer is also available there already, so you can download there. Okay, so now here is some advice if you want to answer section A. So for you have to answer all the questions in this section. So students should not be spending too much time in answering section A. Advisable maximum allocated time is 20 to 25 minutes. So let's say if you use 20 minutes, you solve 15 questions. Basically, it's 1 minute 20 seconds for one question. What am I trying to say in here is do not over focus on one question, especially when you know that the calculation question is very challenging. So when the calculation question is very challenging, okay, so you should not focus on one objective question for like 5 minutes, for examples, okay? So you only come back to the questions when you have available time, okay? So that is my advice if you come to a very troublesome calculation, like some of them which I'm going to share with you later. Okay, so with that next section, let's go on with the first section, which is the section A for the objective. I do hope that you already try on your own at home before you come to attend my talk for today. So let's begin our discussion, shall we? Okay, so we have number 1. In the course of measuring fuel content value, a reaction of conversion of hydrocarbon into water and carbon dioxide is carried out in 2 steps. You have CaHy plus X plus Y over 4. gives CO plus H2O. Then you have CO plus half O2 gives CO2. Okay, so the net reaction takes place simply CXHY plus X plus Y over 4. O2 gives CO2 and H2O gas. So actually, a large fraction of the raw material is converted in one step, and the second step is just to catch the fraction that was partially burned at the first time. So anyway, for the overall or net process, which statement below is definitely always true? So this is basically they are trying to test on your knowledge on defining Hess law. So what is Hess law? So Hess law is basically, okay, so Hess law is basically the enthalpy change of a chemical reaction is the same regardless of the route taken in the reaction. So the one that is closest towards this definition will be C. So enthalpy change of the reaction is independent with the route taken. No matter the reaction is one step or series of steps. Okay, so it's also independent with the fraction which has converted to the two steps in here. Okay, so that is what this best statement is trying to tells you about this Hess law. Okay, so therefore the best answer in here is C. I know, I already removed that. Okay, thank you very much for reminding. Okay, so immediately we go to the second questions. Standard enthalpy change of combustion for xylene C8H10 is negative 3,908 kilojoule per mole. Using this data and the standard enthalpy change of formation for water is negative 285.9, and then the CO2 is negative 393.5. Calculate the standard enthalpy change of the formations for C8H10 in liquid form. Okay, so now how are we going to solve this? So you have to first write out the balanced chemical equation for the reaction, where CaH10 plus 21 over 2O2 give 8 CO2 plus 5 H2O. Okay, and then you use total enthalpy change of the reaction is equals to total enthalpy change of the product minus total enthalpy change of the reactant. Okay, so you have negative 3908 is equals to 8 times negative 393.5. Okay, and then plus 5 times negative 285.9. So enthalpy change minus the enthalpy change of formation for CaH10 plus 21 over 2 times 0. 0 is the enthalpy change of the formation for oxygen. For pure elements, the enthalpy change of the formation should be equals to 0. Okay, so press your calculator. What is the final answer that you get? So your final answer of your enthalpy change of formation is negative 669.5. Okay, so your answer is A for number 2. Okay. Okay, so now if you would allows me, okay, so any questions so far? Never mind. If you have any question, you can always put in the comment. I'll show your comments and then I will answer to your comments in there. Okay. Okay. So thank you very much for helping me to repeat the answer. Very good. Okay. Okay. Then immediately we move on to question number 3. A chemical compound has the molecular weight of 89.05 gram per mole. 1.40 gram of this compound underwent a complete combustion under constant pressure and condition in a calorimeter with a heat capacity of 2980 joule per degree Celsius. The temperature went up to 11.95 degree. Calculate the molar heat of combustion for this compound. Okay, I know supposedly the answer should have negative, but in here let's more focus on the molar heat combustion in terms of value, shall we? Okay, so okay, so you use Q equals to C theta. So here is the problems where sometimes students might confuse. Teacher, when to use Q equals to MC theta, when to use Q equals to C theta. Okay, this Lily asked, teacher, is physical state important? Objective, don't care. Okay, objective, you don't care. But when it comes to structure and essay, yes, you have to write the physical state. Okay, so you must write only the physical state when it is in structure and essay. Objective, just ignore it, never mind. Objective, you want the only answer inside the ABCD. Okay, so don't care. But because I'm doing presentations, of course, I have to give you the complete guide. Am I right? So please don't mind too much about that. Okay, so now back to the question number 3. So some of the students are confused. Teacher, when should you use Q equals to MC theta? When to use Q equals to C theta? So you use Q, you look at the unit of the heat capacity. There are two types of the C, capital letter C and small letter c. capital letter C is heat capacity, while small letter c is specific heat capacity. You can distinguish by using the unit. Okay, so if the unit is joule per degree Celsius, like what this questions is given to you, okay, then you should use Q equals to C theta. But if the questions given to you, especially they in our STPM syllabus, our content is more towards water. So the water is 4.18 joule gram minus 1 degree Celsius minus 1. Then you should use Q equals to MC theta. So that is the difference when you should use Q equals to C theta and when you should use Q equals to MC theta. Okay. Teacher, why can you can't see your slide clearly? I'm not 100% sure what is going on. Why you cannot see my slide clearly? I'm not sure, you know. Okay. So so I hope that is better already. I'm not sure lah. I try my best to this one. Okay. So hopefully it's okay already. Okay. Sorry. Okay. Okay. Thank you very much for all of you for helping me. You can consider. Okay. So I just click whatever. Thank you very much for helping me to explain. So let's resume. Okay, so back to our question. So step 1, Q equals to C theta. So 2980 times 11.95, you have Q equals to 3561. Then you use mole is equals to 1.40 divided by the molar mass, 89.05. So mole is equals to 0.01572. And then you use delta H of combustion is equals to 35611 divided by 0.01572. And then therefore, the final answer is 2265. So therefore, the answer is D. Okay. Okay. So that is for how you are going to answer for question number 3. Okay. Okay. So some of you asked, teacher, is physical state important in chapter 7.8? 7.8 is chapter 1 and 2 for our semester 2 yes, for structure and essay. If thermochemistry, you must write your state of matter. Please, you must write. Okay. I'm so sorry. I have to rush a little bit for this one. I'm so sorry. I cannot talk slowly because if I talk slowly, I'm going to drag a lot of time. So I hope that you can understand that I have to use certain speed when I speak. So I'm so sorry for that. Hope that you can understand. Okay. So the answer for number 3 is D. Okay, I try to slow down. Sorry for that. Okay, so we goes to number 4. Aluminium does not corrode as iron does. Because of what? So this is a very common question. So aluminium on its nature is coated by a layer of the aluminium oxide layer. Okay, so that is why it is protective layers that cause the aluminium does not corrode easily. So this is a very direct question where you have to, by hook or by crook, you have to know. And the technique of how to increase the oxide layer. Okay, the technique of how to increase the oxide layer is by using what technique? Is by using anodization. Anodization. Okay. Okay. So Lily is asking. Okay, sorry for that. Okay. I will focus. Okay. So let's continue number 5. Now, this is one of the type of question that require quite a long process to calculate. So if you understand the questions very directly, you can calculate very fast. But for average students, I will recommend you all you to do not over focus on these questions. So you see this kind of calculation, okay, quickly jump, go to the questions that use most of the time theoretical part. Okay, so still because of the discussion, I have to go through with you slowly. Okay, so let's have a look at question number 5. An electroplating bath containing K2Cl2O7 solution is used for chromium plating. If a current of 6.250 amperes was passed through the system for 6 hours, 35 minutes, 20 second time period, how many grams of chromium would be plated on the object at the cathodes in here? Given to you, Faraday constant is 96,500 coulomb per mole. Okay. For objective, never mind. Later, for significant figure, later I will. For significant figure later, I will stress more in section B and C. So this is section A. So let us focus on section A first. Can later section B and C, I will come back to you. So don't worry, okay? Okay, so let's resume back. Okay, so first you have to use Q. You have to understand by yourself that chromium in Cl2O7 has an oxidation state of +6. Therefore, there are 6 electrons to be involved in the electroplating. That means if you want to turn chromium in K2Cl2O7 to become chromium metal, so you have to accept back 6 electrons. So what am I trying to say in here is there are 6 electrons. 6 electrons inside here lah. Okay. So then you use Q equals to IT, where Q times 6.25 times 6 times 60 times 60, which is 6 hours, plus 35 times 60, which is 4 minutes, plus 20 seconds. Okay, so that is the calculations. And when after you press your calculator, your Q is equals to 148250. Okay, 148250. Okay, then your mole of electron is 148250 divided by 96500. So your mole of electron is 1.5362 mole. Okay, so stoichiometrically, since 6 electron is to 1 mole of chromium, therefore mole of chromium multiplied by 6. Okay, so mass of the chromium is 0.25600 times 52.0, so you get 13.32 gram. So your answer is A. Okay, so so can I survive if I don't answer calculation? Objective, you can tembak ABCD, but when it comes to structure essay, you cannot tembak anymore. So you have to somehow master the calculations. Okay, so that is my advice for you. Okay, in chapter like this, so as I told you later, we will focus on this on section B, okay or not? So for right now, let's focus on section A, objective. I teach you on how to objective, okay? So what is the answer for question 4 just now? Question 4 just now is, what is it back? Sorry, I hide your comment, I hide your comment back. Just now, number 4 is A, okay? Number 4 is A, number 4 is A. You can download the answer from my blogspot, You can download the answer from the blogspot, and inside there, all explanation, everything is there. Okay, so you don't have to copy anything. Okay, so everything is inside my blogspot. You can click the link from the description of my YouTube below. Inside my YouTube, you can this one. Okay, sorry for that. Okay, thank you very much for helping me. Okay, iron objects such as storage tank and underground pipeline can be protected from corrosion by connecting to a wire in the piece of the which metals. So in here, this is a technique called used in oil refinery process called as cathodic protection methods, where more electropositive metals or metal with a greater inert value than iron. Greater inert value, that means more negative. We are looking for more negative of Fe is in contact with the iron pipeline in order to prevent corrosion of the iron. So among the choice A, B, C, D in here, the one that can have more negative inert value compared to iron is magnesium. Okay, so the answer is C. Okay, so that is for question number 6. Okay, then we go to question number 7. Which of the following statement about period 3 oxide from sodium to chlorine is true? Okay, so these are all actually starting from when you enter the chapter 3. All of them are fact. Most of them are facts questions already. So you can answer this very quickly for inorganic chemistry questions. So, but you must have a very strong foundation in inorganic chemistry where you must try your best to understand as much as you can about this one. Okay, so which of the following statement about period 3 oxide from sodium to chlorine is true? So this is the description that says between molecule become covalent bond across the period is too general. In A, the bonding between molecule become covalent bond across period. So this is true general, and we cannot say all of them are covalent. So that is why using these statements to say is that the reactions is the bonding between a molecule become covalent across the period is not quite true because sodium oxide, magnesium oxide, aluminum oxide is ionic compound. Only silicon, phosphorus, sulfur, chlorine oxides are covalent compound. So this statement is general, so A is not true. Okay, then we go for B. SiO2, silicon dioxide react with hydrochloric acid and sodium hydroxide. No, silicon dioxide is acylic oxide which react with hot concentrated alkali solution. Therefore, B is incorrect. Okay, and then MgO, then third C, magnesium oxide readily dissolve in water. Actually, no, magnesium oxide is sparingly soluble in water. Sparingly soluble in water. So that is why C is also incorrect. And finally, D, sodium oxide dissolve in water to form a strong alkali solution. Yes, so sodium oxide dissolve in water to form a strong NaOH with high pH according to the equation. Na2O plus H2O give 2 NaOH. Okay, so the best answer in number 7 is D. Okay. Okay, so this is question number 7. Okay, then we go to question number 8, shall we? Okay, question number 8. An oxide of X dissolve in water, forming a solution of Y which is ready to absorb carbon dioxide gas. X can form Y because X is what? Okay, so oxide X dissolve in water to form Y which can absorb carbon dioxide indicates that X is usually sodium oxide or potassium oxide. Okay, so only this group 1 oxide can dissolve carbon dioxide. Okay, can absorb carbon dioxide. Okay, so when it dissolves in water to form NaOH which absorb carbon dioxide to form Na2CO3. So therefore, the best statement that describes why can be formed due to X is very reactive with water. Now, it might seem that B have a negative standard electron reduction potential is true. Now, this statement is true. However, it does not describe why carbon dioxide, why Y, which is the sodium oxide, is readily to dissolve in water. Okay, you see, like aluminium also have an inert value negative 1.66. But why aluminium does not dissolve in water? Because aluminium is coated by a layer of oxide layer. Now, what am I trying to highlight in here is negative values does not really indicate that it is reactive with water. No, okay, it does not actually describe its solubility inside water. Okay, okay. So with that, that is for question number A, and the answer is A. Okay, so that is for question number 8. Immediately we go to question number 9, shall we? Okay, so question number 9 sounds like this. Which of the following about group 2 element is true? Okay, so A, beryllium chloride is ionic. No, beryllium chloride is covalent. So therefore A is incorrect. Barium sulfate is insoluble in water. Yes. Okay. So in fact, when going down to group 2, only beryllium and magnesium sulfate are soluble in water. Calcium, strontium, bariums are insoluble in water. Okay. So the best answer in here will be B. Okay. C. The nitrates, when heated, form nitrogen dioxide and metal oxide. No, not only nitrogen oxide and metal oxide, they also form oxygen gas. Okay. So C is incorrect. Okay, C is incorrect. And then finally for D, barium has a high charge density. No, barium due to its large ionic radius, it has a small charge density. So the best answer for question number 9 is B. Okay. Okay, so that is for question number 9. Immediately we move to question number 10. Which of the following oxide does not dissolve in water? So which of the oxide does not dissolve in water? So we all know that only silicon dioxide does not dissolve in water. Why? Because it has a giant covalent structure. So this is a very direct question. Okay. Another oxide which is also not soluble in water is aluminium oxide. Okay. So aluminium oxide does not dissolve in water. Magnesium oxide still sparingly. It can, but not very but it still can. So if you have answer in between sodium, magnesium, aluminium oxide will always be the best answer because aluminium oxide cannot dissolve inside water. Okay. Okay. So number 10, very straightforward. The answer is D. Okay. Okay. Number 11. Which of the following electronic configuration is most likely to dissolve in steam than in water? So you must try your best to understand. If you have the electronic configuration, so 1s2, 2s2, 2p6, 3s1 is sodium. 1s2, 2s2, 2p6, 3s2 is magnesium. 1s2, 2s2, 2p6, 3s2, 3p1 is aluminium. And 1s2, 2s2, 2p6, 3s2, 3p2 is silicon. Okay, so the one that only most likely to react with steam but not with water is magnesium. So the configuration, of course, have to, yes, it's magnesium, correct, very good. Okay, congratulations, Mukri. Okay, so that is for number 11. Okay, then immediately we goes to question number 12, shall we? Okay, question number 12. Which of the following group 14 oxide cannot be formed from direct combination of element with oxygen? Okay, so if you look carefully, inside here, CO2, SiO2, GO2, and PbO2, which one it cannot form? You must know by yourself that when going down to group 14 oxide, +4 oxidation state stability decrease, while the +2 oxidation state stability increase. Therefore, when heated with oxygen, lead will form PbO instead of PbO2. So the only lead that will not form O2 is lead. Okay, so the answer is D. Okay, so that is for number 12. So straight away we go to number 13. Which of the following properties increase on descending group 14 of the periodic tables? Okay, so now in here you need to understand a few characteristics of this group 14. So when going down to group 14, acidic characteristic of the oxide, acidic characteristic of the oxide decrease as it go from acidic to amphoterics. This is due to the covalent characteristic decrease as when the atomic radius increase. So that is why it goes from acidic to amphoteric. Okay, then number B, the covalent characteristic of the chloride is also decreasing. Why decreasing? Because as atomic radius increase, it is less polarizing. So therefore, the covalent characteristic also decrease. And then we say C, ionization energy of the first two electron. So ionization energy when going down to all group are all decreasing. Okay. However, for lead has a slightly higher ionization energy compared to tin. Okay. Does anyone know why? Why does lead has a slightly higher first ionization energy compared to tin? Okay, so as you must know that it is due to the ineffective screening of the 4f orbital. Ineffective screening of the 4f orbital that causes the effective nuclear charge to be slightly greater. So that is why the ionization energy of lead is slightly higher than that of tin. Okay, so you must know by this fact. Okay, so that is for C. And then for D, electrical conductivity, yes, increase. Why? Carbon, as in diamond, is an insulator. Silicon, germanium are semiconductor. And then tin and lead are metal, therefore conductor. So the only properties that is increasing is the electrical conductivity. Okay, so some of you start to answer inert pair effect, closely packed, that are all not true. Why the first ionization energy of the lead is higher than tin is due to ineffective screening of the 4f orbitals. So you have to know this by yourself. I'm so sorry. You have to know this by yourself. Okay. Okay, so with that, that is for question number 13. Immediately we go to question number 14. So in the sequence of HCl, HBl, HI, which statements are correct? Okay, so number 1, the enthalpy change of formation become less endothermic. So enthalpy change of the HCl, HBl, HI, yes, is decreasing because of the increasing size. Therefore, the stability also decreased. So that is why the delta H of formation is also decreasing. So number 1 is correct. Whereas number 2, the polarity of the hydrogen halide also decrease. Why? Because the difference of the electronegativity also decrease, has lens polar. So number 2 is wrong. And then number 3, the thermal stability of the hydrogen halide decrease, which is true, as the atomic radius increase. So atomic radius increase at the same time also cause the acidity to increase. So therefore 4 is also correct. So in here 1 is correct, 3 is correct, 4 is also correct. So the answer in here will be C. Okay. Okay, so that is how you are going to answer for question number 14. Okay. Okay, last but not least, we goes to number 15. So number 15 is D block questions. When an aqueous ammonia is added to aqueous copper 2 sulfate without shaking, no shaking this time, the appearances in the test tube is shown below. What is the formula of the pale blue solid in the central band? Okay, so before answering what is the central band, why don't we answer what is the blue solution and what forms the dark blue solutions? Okay, so the dark blue solution, the blue solution is due to the formation of what? So the blue solution is due to the formation of CuH2O6 2 plus. Now, what about the dark blue solution? So the dark blue solution is due to the formation of CuNH3 2 plus. Whereas the center band, which makes the band color with a pale blue solid, okay, so it is a precipitate. It is a precipitate. So the only one that forms precipitate is copper hydroxide. And the one that's best suits the description in here is CuNH3 2 plus OH2 minus. Okay, so the best answer for the central band is actually C. Okay. Okay, so with that, that is for the first 15 objective questions that I can share with you for section A. So I hope that you are able to understand it well. So so any questions that you want me to ask me for the section A part? Thank you very much. So nice of you. Thank you very much, Ru Suan Jun. Okay. Thank you very much to those who missed it. Thank you very much for helping me to retype the answer. So nice of you. Really appreciate that. Okay. So if you missed that, your Miss Ru Suan Jun is helping you to type out the answer. Okay. Sir, do applications important or not? Application, I cannot say not important, but if you want, it's usually application is just 1 or 2 marks only. So if you really look important, this 1 or 2 marks, then you better memorize. So why is the coordination number CuNH3 is 4, not 6? This one you have to memorize. I'm so sorry. You have to memorize. CuNH3 4 is this one. I suggest some of the questions, if you are not really understanding about the concept, you might want to refer the international reference books. That is the best. Or you refer to Google. Okay. Okay, so I hope that all of these are helping you already. Okay. So because of the time constraint, I'm going to go to the structure questions. Okay, shall we? Okay, so let's together go to the structure questions. So a little bit advice, we go for the structure questions is following. Okay, so for section B, another 15 marks. So a little advice is, okay, sorry, I scroll back. Some of you start to ask questions already. Teacher, for question 15, where does the OH minus come from? OH minus comes from the, because ammonia is a weak base. Ammonia is a weak base. So ammonia will dissociate some OH minus. So the copper ion will react with the OH minus to form the pale blue precipitate. Okay. So I hope that it answers you. Okay. So ammonia is a weak base. So when weak base, it dissociates some OH minus. So the Cu2 plus will react with the OH minus. Okay. Okay. Thank you, Miss Ru Suan Jun, for answering for me again. Okay. So I hope that you all catch it. Okay. So let's resume back. Okay. So let's together focus on the section B for now. So section B, my advice to all of you is you're only able to spend 15 to 20 minutes answering this section. So answers should be short and clear and do not over focus in one question. Basically, structure question is either you know or don't know. Okay, so if you know, you can straight away answer. If you don't know, no matter how much you think, you maybe need some time, but rather than wasting time thinking of the answer, I would suggest you to move on to the section C, essay, so that you don't waste time. 90 minutes is truly quite short. So that is my advice to you. So hopefully you'll be able to understand. Okay, so now let's have a look at the structure questions. Oh, Lu Suan Jin, your boy. Sorry. Thank you very much. Mr. Lu Suan Jin. Okay. Sorry, please don't feel offended. Okay. Okay, let's focus on number 16. Okay, number 16 sounds like this. Diagram over shows the laboratory illustrator of a simple hydrogen-oxygen fuel cell. Okay. Okay, so this is the cell diagram. You have oxygen, gas, 1 atmosphere. Now, this fuel cell is an acidic fuel cell. In fuel cell, we have two types. One is acidic, one is alkali. So this case is acidic fuel cell. So I purposely choose this question because I feel that you need to know about fuel cell. Fuel cell, long time didn't ask in STPM already. So try your best to remember lah. Okay. In STPM, you are not given the data of the standard electrode potential. No, you're only given this. You are only given these periodic tables only. Now, for E naught value, if they want to ask you anything about E naught value, they will give you on the question itself. Okay, they will give you on the question itself. There is no such thing as data booklet for the E naught value. But in my case, because I want to save your paper lah, so I said that, okay, might as well I give you the whole data booklet for the E naught value so that you don't have to, waste paper lah. Okay, so I hope that you understand this. Okay, okay. You will give in the question. Okay, thank you very much, Chong Wei Xiang, for answer for me. Okay. So does the inert electrode stand with black platinum only? Either platinum or black platinum. Usually it's this. Okay. Inert for our Cediverse is usually platinum. Okay. Sometimes they use the word black just to highlight that it is passive. Okay. 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 So back to the presentation. Okay, so let's answer. So A, write the half cell for the reaction occur in the left hand, the oxygen electrode when the cells operate. Okay, so in here, you have to know how to write your half equations. Now, because this is acidic fuel cell, so for acidic fuel cell, your half equation will be 4H plus O2 plus 4E minus give 2H2O. Teacher, is state of matter important or not? Now, I would suggest you to write the state of matter. Yes, okay. I would suggest you to write the state of matter in this case. Data booklet, I think, does data booklet give you or not? I think data booklet does not give you. Okay, if data booklet does not give you, don't have to write. But if the data give you, they write the state of matter out, then you should also write your state of matter out too. Okay, so that is my suggestion for you. Okay, you only write when you are given. Okay, okay. So that is for the half equations occur for oxygen. 4H plus O2 plus 4E minus give 2H2O. Okay. So this means the beaker at the left side will have more liquid. No. This is not electrolysis of water. No, this is fuel cell. Nothing to do with the which one has more liquid, which one has less liquid. No. So when anode discharge OH minus, should I use these half equations? I'm from Selangor. Okay. No. In this case, that's why I told you, a hydrogen-oxygen fuel cell, you have two types. One is acidic type, one is alkaline type. The one that you write in here is alkaline fuel cell. But the question is asking acidic fuel cell. So this is the half equation for acidic fuel cell. Okay. Okay, so I just asked only if gold is an inert element, why gold is not used? Because expensive lah. Gold is very expensive. You want to use gold for experiment? Why don't you just give it to me? Okay. Okay. Thanks for your curiosity. I hope that that's solved. Okay. Teacher, if I write 4H O2 plus 4H plus 4E minus give 2H2, can. The order does not matter. As long left side is left side, right side is right side. Okay. Okay, so shall we focus back on this one? Okay, so number 2, using the data booklet to calculate the voltage produced in this cell. So you use E naught cell is equals to E cathode minus E anode. So positive 1.23 plus 0, so your E naught cell is positive 1.23. Now, for this hydrogen-oxygen fuel cell, no matter it is an acidic fuel cell or alkaline fuel cell, E naught cell is definitely positive 1.23. Now, if you want to know more information, you can always go to my blogs, to my videos of the lesson to look back about the fuel cell. Sorry, I cannot explain much in my current live view because I have a restriction of time. So I hope that you understand that. So if you want to view back, you can always view back from the YouTube lesson. If you buy my books also describe both of them. So I hope that that helps you. Okay. So no need to write state of matter. As I already told you just now, if the data booklet, if the information does not give you state of matter, then in this chapter if the data if the information does not give you state of matter, then you don't have to write the state of matter. But usually all these state of matter are quite simple, so I would advise you all to write. I will advise you all to write. Okay, so shall we focus back? Okay, then we go next to question number C. A fuel cell is an orbiting satellite is required to produce a current of 0.010 ampere for 400 days. So calculate the mass of the hydrogen that will be needed. Faraday constant 96,500 coulomb per mole. Okay, so in this case, because you are focusing on the hydrogen, how much hydrogen that is needed. So in here, it is the hydrogen. So the half equation that occur at the hydrogen half cell is H2 plus 2, give 2H plus 2E minus. Miss Yu Ching, I've already explained earlier. You can maybe view back later. This is an acidic fuel cell, not alkaline fuel cell. So your answer cannot be accepted. Okay. When you write the half equation, then you use Q equals to IT or Q times 0. Now, when you calculate, please substitute as exactly given to you in the question. If the question gives to you 0.010, you substitute 0.010. Don't substitute 0.01 only. So you have to, my keyword in here is substitute as exactly given to you in the questions. Okay, so 0.010 times 400 times 24 times 60 times 60. So you get your Q is equals to 345600, right? Then you calculate your mole of electron. So mole of electron is 345600 divided by the Faraday constant 96,500. So you get 3.581 mole. So from the half equation above, since 2 mole of the hydrogen, 2 mole of electron give 1 mole of hydrogen. So mole of hydrogen is 1.791 mole. Therefore, the mass of the hydrogen is 1.791 times 2 times 1.0. You get the 2 significant figure, 3.6 gram. Okay. So teacher, how do we know how many significant figure that we use in this question? If you look carefully, 0.010 is 2 significant figure. 400 can be 1, can be 2, can be 3, isn't it? So in here, the best way to tell how many significant figure that you use in here is by looking at 0.010. So 0.010 is 2 significant figures. So that's for your final answer should also be in 2 significant figure. Okay. So I hope that this will clear your doubts on teacher, how many significant figures should I use in my question? It should, for your answer, your significant figure of the answer depends on the questions. Okay, if question give 2, then your final answer should also give 2. Okay. Yes, significant answer, significant figure is only important in the last question. Yes, you are right. Okay, it is only important in the final answer. Throughout your calculation, you see if in the examples in here, you see my calculation have 4 decimal place, 5 decimal place, isn't it? A 4 significant figure, 5 significant figure, isn't it? Now try your best to write at least 4 and 5 during your calculations, because for accuracy purpose, some of you have the habits to zero back your calculator and recalculate, isn't it? So if you want to recalculate and you zero back your calculator, you want to recalculate back. So I will recommend you all to write at least 4 to 5 significant figure for accuracy purposes. Okay. So, sir, could we write another calculation for unit conversion? Actually, no need unit conversions. Unless the questions want specifically kilojoule per mole, let's say. If the question specifically 1 kilojoule per mole, then you have to divide by 1000. But if the question does not say that it must be kilojoule per mole, even if you write, let's say, 1.2 times 10 power of 6 joule per mole, also can. Okay, I'm just stating examples in here. So you can use any power form, never mind. You don't have to really convert joule per mole to kilojoule per mole. Not necessarily. Nobody asks you to do that. Okay, teacher, how about mark allocation? Okay, the 3 marks in here, marks allocation, you, okay, I straight away tells you in here, 1 mark, first mark goes to calculating Q equals to IT, second mark goes to calculating the mole, third mark goes to calculate the mass of the hydrogens in here. For marks allocation, for more details, you can go to the answer scheme. I've already give you the answer scheme through my blogspot. You can refer there lah. I'm just showing you the correct technique of how to answer as a student. As a student, for you all as a student, you don't care where are the marks located. Okay, you just try your best to solve as well as you can. Okay or not? Okay. So I'm so sorry lah. Okay. So teacher, if given more significant figure, it will deduct mark. No, in STPM, we don't deduct marks. Don't worry, we never deduct marks. Either have marks or no marks. 1 mark or no mark. We will not negative. No. Either have marks or no, 1 mark or 0. We will not minus. Okay. Okay. Use this one. Teacher, how about I use another formula, Ix equals to NF over Q? Some of you, I know you're very good with calculations. This is the points where sometimes I tell you this, I'm so sorry to say this in my live YouTube. I would usually recommend students to write step by step, Don't use this summarized formula. Why I say don't use summarized formula like this is because not all examiner understand, Not all examiner understand. That's what I can say lah. Okay, if I'm the one who mark your paper, I understand. I see your formula. Okay, this student correct lah. Okay lah, give marks lah. But like I said, not all examiner understand. So don't risk it. You write one by one. Okay. Okay. Yeah. Teacher, if I round off the value of the previous step, will it affect the final answer? Yes. That's why I said when during the calculation, you should write 4 to 5 significant figure. Okay. In STPM, we only usually have one answer only, which is we know the answer which is by not zero the calculator. Okay. If possible, throughout your calculation, don't zero back your calculator. That is the best. Okay. Okay, so I guess that is all. Okay, so shall we proceed? Because of the time constraint. We still have essay not yet finished yet. Okay, D. State one advantage and one disadvantage of using fuel cell to power road vehicle compared to hydrocarbon fuel cells such as petrol. So the disadvantage in here is, advantage is no pollutant produced because the product is pure water lah. Okay. However, the disadvantage, we have quite a lot. You just need to write one. Hydrogen is hard to store. It is expensive and it is not durable. So that is why we don't see fuel cell apply in our daily transport lah. Okay. Nowadays, we are more towards EV, electrical vehicle. That one is more economic. Okay, so we are moving towards that because most of the electrical vehicle nowadays, we use rare earth elements. Okay, but this is just applications. You can, this one. Okay, so teacher, may I know what is the equation right in and not? No. You can check the answer, please, Miss Xiu Qing. You can check your answer from the answer booklet. Environmental friendly can. Okay. Sawmill toy. If environmental friendly can. We accept that answer. Environmental friendly. Advantage. Environmental friendly can. Okay. Dangerous cannot. Dangerous cannot. We don't use that word dangerous lah. Okay. Okay, and then sir, for electrochem, if the concentration of solution at cathode increase, do we need to show calculation? If it is not that 1.0, then you use Nernst equation. Yes, you have to use Nernst equation to answer. Okay. Advantage, zero carbon emission. In here, we are focused on fuel cell. We are not focused on hydrocarbon cell. Okay. So we focus on fuel cell. So zero carbon emission. I don't think they are going to accept that. Okay. Okay, do not pollute environment. Can. Okay, okay, okay. So 3.52, no. Two decimal place, two significant figure, not two decimal place, two significant figure. Okay, two significant figure. Is there any other advantages other than no pollutant? No, only one. That is the only advantages of fuel cell. No, because it is not it releases a non-pollutant. That is the only advantages. Okay. Yes, fuel cell easily flammable because you use hydrogen, you use oxygen. Okay. Okay. So can we move on? Okay, 1 hour. I cannot answer everything. Okay. Sorry. Okay. I try my best to select a few and then I see which one is relevant, so I answer Okay. Thank you for that. Okay. Okay. Number 17. This is transition elements. Okay. So iron is a transition element which is important elements applied widely in our daily life. For example, in the transportation oxygen to hemoglobin in our body, and also apply as a catalyst in industry in the reaction between Prosulfite ion and iodide ion. Okay. A, define transition elements. Okay. So what are the two keywords that you have to define whenever you are defining transition element? So the two keywords that is important when you try to define transition element is element that can form more than one stable ions. First keyword. Okay, form more than one stable ion. First keyword. Then second keyword, incomplete field d orbital with incomplete field d orbital. So these are the two keywords that you have to know on how to define transition element. Okay, so try your best to define. Okay, so that is for 17A. Okay, immediately we move to 17B. The reaction between iodide ion and Prosulfite ion is slow, and the reaction can be speed up by adding a small amount of Fe3+ ion. The following two steps reactant taken place is given in the equations below. So you have 2I minus plus 2Fe3 plus give I2 plus 2Fe2 plus, 2Fe2 plus plus S2OA2 minus give 2Fe3 plus. Teacher, if half cell, sorry. Okay, I show you. Teacher, what if we say at least one? No, it must be one or more than one. It cannot say at least one, more than one. Okay, this one. Teacher, is half fill or incomplete fill? No. Why don't you straight away use? Okay, we can accept because you said the word incomplete. We can accept, no problem. We go in some year. I heard the lecturer say we also accept partial fill. They accept that. They said partial fill also accepted, so we accept that. No. Cannot say at least one. No, you must have two. Okay, if you say two or more, can. Two or more, can. More than one, two or more, can. Okay. D subshell can lah. The keyword is incomplete fill d orbital, d subshell lah, whatever, doesn't matter. Okay. My teacher said calculating plus minus answer decimal place smallest. The one you have to answer to your question. Okay. For me, dear all the students that follow my YouTube live, I only share what I know. So what I don't know, I don't want to share. Okay. What I don't know for what? How am I going to share? Okay. So if you have anything your teacher teaches you or whatsoever, I always encourage students to follow your teacher, because your teacher is always your best reference okay. Do not argue with your teacher. And one more thing, don't say Mr. Chu said one. I tell you, if I haven't heard this statement come out from any one of you, because Mr. Chu said, I kill you personally, then I kill myself. Please do not use my name. I tell you. Okay. So this one. Yeah. This is from the NPM Sukatan. Yes, thank you very much, Yu Qian. Okay. So shall we move on because of the time constraint? Okay. So B, write an overall equation for the catalytic set below. So in here, you cancel in between the step in here. So inside here you can cancel Fe3 plus cancel with Fe3 plus. Okay. Then Fe2 plus cancel with Fe2 plus. Okay. Okay, so you get your overall equation to be your overall equation in here will be 2I minus aqueous plus S2OH 2 minus aqueous give I2 aqueous plus 2SO4 2 minus aqueous. Okay, so teacher, state of matter important or not? Yes. In this case, yes. Why? Because questions given you state of matter. Your answer must also write state of matter. Okay. Okay. So this is the thing, huh? Okay. And then hey. And son, please don't do that. Okay. I purposely highlighted your comment. Huh? Okay, whatever. Okay, let's continue back. Okay, B, what is the catalysis occur in here? So, and then the overall equation is also trying to tell you that this is a homogeneous catalyst. This is a homogeneous catalyst. Huh? Okay. Okay, so teacher, can I just say homogeneous? Okay, can. If you just use the word homogeneous, can, no problem. Okay. Okay, so, and then C, state and observation that may take place in the catalysis, step 2. Teacher, if state of matter wrong still got mark. No mark. In here, very straightforward. State of matter is very straightforward. So there's no way for you to copy wrongly. So state of matter wrong, then answer also wrong. Okay. Catalysis, catalytic, whatever. As long as the word homogeneous is there. Even if you don't write catalyst, you just write the word homogeneous and acceptable. Okay. Okay, so shall we continue? Okay. And so for C, state observation. So Fe2 plus is green. Green solutions turn to brown or turn to yellow. Either one are accepted. Okay. But the best is still brown. The best is still brown. Okay. Okay. So that is for number 17C. Okay. So this is for question number 17B3. Okay, sir, the observation, I write the Fe, can I write orange instead? No. Either yellow or brown, cannot orange. Okay, no orange. If the oxidation, I write Fe undergo oxidation. Observation is physical changes that you see with naked eyes. Cannot write Fe undergo oxidation, cannot. This is explanation. Okay, this is explanation, cannot. Okay. Okay. So thank you. Okay, thank you. So let's move on. Okay, then we go to question number D. Draw an energy profile showing the difference between catalyzed reaction and uncatalyzed reaction between the exothermic reaction of iodide ion and prosulfite ion. So the question already says that this is an exothermic process. Okay, so in here, first mark will definitely goes to stating that this process is an exothermic process. Okay, so this is the original profile. In the red line in here is the non-catalysis profile. The purple line is the catalytic reaction. So first mark goes to drawing the graph for catalyzed reaction. Second mark goes to drawing the graph of uncatalyzed reaction. Third mark goes to label. Okay, third mark goes to label. Okay. Color changes must have there in answer. Yes. Okay. Okay. So I repeat, in here the 3 mark goes, first mark goes to the catalyzed reaction, second mark goes to uncatalyzed reaction, third mark goes to label. So teacher, if I go to the wrong this one, can I get marks? Yes, you can. You cannot get mark if you label wrongly. 1 minute, sorry. Thank you. Okay. Okay, so I hope that is clear enough. Homogeneous. Homogeneous is American spelling. Homogeneous is UK spelling. We accept UK and US lah. We accept lah. Don't worry lah. Okay. Not house telephone. Not house telephone. This is doorbell. Okay. Homogeneous, NEOUS, is UK. Okay. Yeah, we don't care about US, UK lah. Correct lah. So okay. So with that, that is all for the structure questions. So any else question that you want to write? So if catalyzed reaction only have one curve. Oh, okay. I forgot to mention this. Okay. In this case, one curve because overall is one step. So one step, one curve. Two step, two curve. So if your catalyzed step, you write only one curve, then we will penalize on the catalyzed reaction. It must strictly two curve. Okay. It must strictly two curve. Okay. Okay. Thank you very much for helping me to remind. So one step, one curve. Catalytic step is two step, so two curve. So if you write wrongly, then no marks for the for the catalyzed reactions. Okay. Okay. Hope that it answers. Okay. Okay, so let's continue. Okay, so with that, that is all for the structure questions. Okay. Okay, so without annexation, let's move on to our essay questions. So for essay question, we are going to discuss all 18, 19, 20. Are you ready? Okay. So never mind. Sorry, I scroll back. The second peak have to be lower than the first peak. Usually is that case. That is the case. Usually that is the case. But if you accidentally draw higher, we also won't penalize because as long as there is two peak, which one higher, which one lower, we don't really mind that much. As long as there is two peak, okay? Even if you draw the same height, also we accept. So, like I said, we do not penalize, or we don't bother too much about who is higher, who is lower, because we are not really going into very detail of that. Okay, so don't worry. Teacher need to write reactant product. Yeah. Need to write reactant product. Yes. Can you write on your own? Sorry, my slide I didn't write reactant product. So can you label on your own reactant and product? Thank you very much, Zixing, for helping me. Okay, Ken? Okay, so that is for number 17. Okay, so can we move on to the next one? Okay, so finally we goes to the final part of this our discussion today, which is essay question, and I believe that you all are very concerned about how to answer essay questions. Okay, so with the session, let's move on. Okay, so my advice to you: spend 20 to 25 minutes per essay in this section. So do your best to present in an essay full with content related to the question. In STPM essay, we do accept point form, table, mind map. Okay. However, we are not really advisable unless you are really confident with your answer. Okay. So we accept any point of the presentations as long as you answer properly with the correct important point. Okay. Okay. So without annexation, let's go on to this. This live stream will permanently be in my YouTube, so don't worry too much. Okay, it will be permanently in my YouTube. Okay, so that means that we have to write as much as we can, write with facts. Okay, one thing that you have to be very careful with essay is do not write contradicting statement. What do I mean by do not write contradicting statement? Is like this. So you can, let's say the answer asks A and B, which is more exothermic. You said A is exothermic, then you put explanation. Later in your second paragraph, you said B is more exothermic, then you put your explanation. So you are asking us like 50-50 back, you know. You cannot do this kind of the explanation, okay? So please do not write contradicting statement, okay? Okay, thank you very much. Is diagram allowed? Yes, can. You can point form, table, mind map, diagram, whatever can. Okay. Okay. So shall we go to the? shall we go to our questions? Okay, can I? Okay, okay. So let's focus back on our questions. So in essay question, let's begin. Okay, question start for 18 is the chapter 1 thermochemistry. So I hope that using these examples, I'll be able to help you all to answer as much as you can. Okay, so let's begin. Okay, so this is not chemistry triathlon, objective structure essay. It is chemistry triathlon. First objective, then structure, then essay. Okay. Okay, so let's go back to this one. Okay, so question number 18 sounds like this. Enthalpy change of a solution for reaction is calculated by using enthalpy change of hydration and also Lattice energy. A. Define standard enthalpy change of solution and Lattice energy of a substance. Okay, so how do you define? So I will always encourage students to know how to define all enthalpy change of reaction. We have 9 enthalpy change of reaction: formation, combustion, neutralization, atomization, ionization energy, electron affinity, lattice energy, hydration, and also solution. So you must try your best to define all enthalpy change of the reactions if possible. So you must define that. So if the question asks, define lattice energy and enthalpy change of solution, you define like this. So lattice energy is the energy released when 1 mole of solid ionic crystal lattice is formed from its oppositely charged gaseous ion under standard condition. Word by word, all must be there. These are all the minimum keyword that you must have in order to get full marks in here. Okay? Okay. Okay. Bond energy should also, yes, bond energy should also be defined. There is 1 year that asked bond energy, 2015, if I'm not mistaken. Okay, bond energy must also be included. Yes, thank you very much, Anson. Okay, so then enthalpy change of solution is the heat change when 1 mole of solute is dissolved in excess water to form an infinite dilute aqueous solutions under standard condition. So every definition just ends up with the word under standard condition. Okay, just ends up with the word under standard condition. Okay, so must end this. Do I need to state standard condition 298 Kelvin? This one no need to state exactly. Just write under standard condition is far more than enough already. Okay, so don't worry. Okay. So if lattice energy is the heat release accepted, we use the word energy better Energy better because lattice energy so you use the word energy. Okay. Enthalpy can. Okay. In this case, enthalpy can. Okay. Enthalpy can. Okay. So can we move on? Okay. So let's move on. So this is how you answer 18A. Okay, immediately we move to 18B. Okay, table below shows the information that of the solution of lattice energy and some salt. 1. Compare and explain the solubility between sodium chloride and sodium iodide. Okay. Okay, so compare and explain the solubility. So in here, I'm going to use point form to explain. Okay, so in here, of course, if you look carefully in the informations in here, you look solubility, you look for the solution. Okay, don't look at, you look for the solution. So we first compare with the solution and we use the lattice energy as our supportive information to explain why is it that the NaI is more soluble in water. Okay, so here are the few suggested answer in here. And of course, in my place here, I will also suggest additional content in here. Okay. So in here, try your best to say that NaI is more soluble in water compared to NaCl, 1 mark. Okay, and then since enthalpy change of the solution of NaI is exothermic while NaCl is endothermic. So I would also advise you all to say that since it is endothermic, therefore exothermic, therefore it is soluble in water, while NaCl is endothermic in here. Okay, then you have to use from the angle of the lattice energy. So why do we use lattice energy at in this angle? It is because you might also want to add this point. I will highlight right now inside my additional. You can catch up later lah. Okay. 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 In here, you can also add the enthalpy change of solution is equals to the enthalpy change of the hydration minus lattice energy lah. Okay. Okay, so you might also want to add this statement inside your answer lah. But I'm looking at from the angle as a student. Okay, so try your best to describe as fully as you can. Okay. 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 So inside here. Okay. So and then why is it that lattice energy is NaCl is greater than NaI? So because when you have a higher lattice energy, your solution will be less exothermic or more endothermic in here. Okay. And then last but not least, you also have to explain since interionic radius between NaCl is shorter than the NaI due to the Cl has a smaller ionic radius compared to I minus. Okay, so try your best to describe as fully as you can in here. So teacher, Mr. Chu, if I said value is exothermic, does it give marks also? No. We do not use abbreviation in STPM. We do not accept negative VE. No, you must use the word exothermic. Cannot use abbreviation. Okay, cannot. Okay, Ken, shall we continue on? Okay, so these are the key points that you have to write out whenever you are trying to explain the solubility of this one. Okay, okay, so let's move on. Okay. Number B2, table below shows the information 2. Using Hess law, calculate the enthalpy change of solution for potassium iodide Ki. Okay, so how are you going to use the Hess law? So when the question already said use Hess law to solve this, I would definitely recommend you all to write all the enthalpy change of the reactions in here. Okay, write the equation for all of them. As a student, you must be able to do this. Okay, so when you write all enthalpy change of the reaction, where NaCl, Na plus gas plus Cl minus gas in NaCl, this is the lattice energy, and then for solution, NaCl solid give Na plus aqueous plus Cl minus aqueous. So until you are able to identify what is your number 8 equation. So the number 8 is the one that you want to find out, where Ki solid give K plus aqueous plus I minus aqueous. Now, I have to admit that this is a little bit challenging. So you need to figure out in between these 7 equations, from number 1 to number 7, how should you manipulate your equations in order to get equation number 8? Okay, so if you really understand about Hess law, you will eventually figure out that you need to reverse equation 1, equation 4, and also equation 5. Okay. Okay, so now after you reverse this equation, 1, 4, 5, okay, so you rewrite your equation again, okay? Yes. If your questions only ask for enthalpy change, all definition just end up with the word under standard condition, okay? Just write. Don't care whether it has mark or not, just write, okay? Just write under standard condition, okay? Okay, so back to this one. So now you have the rewrite values in here lah. So you can start to cancel already. Are you ready? So let's together learn how to cancel one by one for all of these. Then you'll find out that what you want. Okay, so first you cancel Na plus with Na plus. Then you cancel Cl minus with Cl minus. Yes, have to look at the state of matter also. Okay, then you cancel NaCl solid to NaCl solid at the 5th equation there. Then you cancel I minus gas with I minus gas, equation 2 and also equation 4. Then you cancel NaI solid with NaI solid from number 6, number 2 and number 6. Then you can also cancel K plus gas from number 3 with K plus gas from number 4. Then you can also cancel KCl solid number 3 with KCl solid number 7. You can also cancel Na plus from number 5 to Na plus number 6. Last but not least, you can also cancel I minus and also I minus aqueous from number, sorry, not I minus aqueous, I minus aqueous must reserve. Supposedly Cl minus aqueous, sorry, Cl minus aqueous, okay, Cl minus aqueous, sorry for that. Cl minus aqueous, sorry for that. Cl minus aqueous with Cl minus aqueous. So at the end, do you see that what is remain inside here? At the end, remains is Ki solid, give K plus aqueous plus I minus aqueous, enthalpy change of solution is 43.1. So sir, what if I use the flow chart method? I tell you, these questions, if you use flow chart, you will never get your answer. Trust me on that. You have to use Hess law. Okay, and whenever the question said Hess law, okay, whenever the question said Hess law, in another word, you have to state out one by one for that. Okay, you have to state out one by one. Okay, I have to write equation. Use the equation. Use this method. Cancel method to get to your final answer. That is Hess law. Okay, so I know that some books, maybe some of your teachers, they use different methods. I'm not going to say that they are wrong, but for me personally, I would always encourage students to use these methods to this one. So what happened if I use the flow chart method? To be honest, usually for me as a marker, I will see whether, okay, the points is like this. First mark to fifth mark is all given in the equation. Whenever they ask you for Hess law, the marks is definitely there. Okay, the marks is definitely right from the equation, the origin of the equations. Okay, so by hook or by crook, all equation together with state of matter. State of matter is a must in thermochemistry. Okay, state of matter is a must in thermochemistry. So you must use your equations for that. Okay. So please don't use the this one. So that's why I said Hess law is always the safest method for you to get the maximum mark in essay. So use this method that I'm showing to you right now on the screen in here to solve whatever question has to do with dealing with equations involving thermochemistry. Okay, so if you really want the highest mark, you use this method, I will guarantee you it is always the safest way to get the highest mark in terms of calculations. Okay. Yeah, too much to write in the flowchart method. This is what I agree. Okay. Okay. This is not Born-Haber cycle, so cannot use. Sir, is the number in the bracket is what, sir? The number in the bracket represent equation 1, 2, 3, 4, 5, 6, 7, 8. Okay. So is it necessary to write the unit? Of course, you have to write the unit. Okay, this is a standard enthalpy change of solution. So kilojoule per mole is a must. Kilojoule per mole is a must. Okay, during the methods, never mind. You don't write the unit, never mind. During the step, during the step, you don't write unit, never mind. The unit is only important in the final answer. Okay, the unit is only important in the final answer. Okay. Okay, sir, how about I summarize the lattice energy and enthalpy change of solution in enthalpy change of hydration, the equation? Because in here, you want enthalpy change of the solution, They do not give you hydration, isn't it? So maybe later privately you can show me your methods and then I will check for you because I cannot figure out if you use hydration. And I think it will be much more complicated if you use hydration. This is a very straightforward methods for you to get to the answer. If you twist turn, you calculate hydration, it will bring you to the it will bring you to Egypt, then come back to Malaysia. You know, you understand what I mean or not? It gives you very, very far away. Okay. Okay. So why don't we follow the list in two significant figures? So when the question said, when question said use Hess law, then use this cancel method. Yes, always work. This is definitely always working. Okay. So I would like to question in significant 2. My answer is 10.49. So we will answer 10 or 11. What is this? No, I don't know. You have to show me your question. I don't know what you are talking about. Okay, sorry. Okay, so shall we continue on? Okay, so with that, that is for essay question number 18. So immediately we goes to essay question number 19, shall we? Okay, because of the time constraint, sorry for that. Okay, so question number 19 is group 2. So question number 19 sounds like this. To make agricultural limestone calcium carbonate is first heated to a higher temperature in a lime kiln, and a calculated amount of water is added to the product form. A highly exothermic reaction occurs and a white powder called as slaked lime is produced. Okay, so A, construct a balance equation for the reactions. So in here, first you calcium carbonate when heated, you become calcium oxide and carbon dioxide, isn't it? Then this calcium oxide, you further dissolve in water to form calcium hydroxide. So these are the two equations in here, okay? These are the two equations in here. Okay, then number B, suggest a reason for using lime in the agriculture. Can you give me like 2 minutes? Because it's raining outside, I have to get something. Sorry, 2 minutes only. Sorry, 2 minutes. Take a break. Okay, we are back. Sorry, I went to pick up my clothes a bit. Sorry. Ayo, just 5-minute break. The view already dropped to 800. Okay, I'm so sorry for that. Okay, so let's continue, shall we? Sorry for that. Okay, so then 19B suggests reasons for using lime in agriculture. So the reason why we use lime in the Agriculture is because to neutralize the acidic soil. So this is the reason why we use a line in the agriculture. So it is for neutralizing the acidic soil. Okay. Okay. So that is for B. And then C, describe and explain the temperature required, how the temperature required to decompose carbon 2 nitrate vary down to the group. So this is the, how are we going to explain the thermal stability of the group 2 carbonate when going down to group 2 carbonates? Okay, so every time when you want to explain this, there are basically 8 very important key points. Okay, there are basically 8 very important key points that you need to highlight whenever you are trying to explain the thermal stability of the group 2 carbonate. So what are the 8? Number 1, of course, you must say that the thermal decomposition decrease when going down to the group 2. Thermal stability increase when going down to the group 2. Okay, thermal stability increase when going down to the group 2. Then second key point is writing the equation. Okay, but since the equation is already written in A, so even if you rewrite again, never mind. Just write as a student, you just write. Okay, that is number 2. Rewrite the equation. Then you start off by using the small ionic radius. Okay, so for example, you use that when ionic radius increase down to the group, or if you want, you can also use from the angle of, let's say, beryllium ion has the smallest ionic radius. Then smallest ionic radius will have high charge and small ionic radius will give high charge density, 4th key point. Then the 5th key point will be high charge density give high polarizing power. Okay. Then the 6th key point stated that high polarizing power will distort the electron cloud of the large carbonate or nitrate or hydroxide ion. So no matter which one you are using, they are all the same. Okay. Then number 7, weakening if carbonate, hence weakening the CO bond. If nitrate, hence weakening the NO bond. If hydroxide, hence weakening the OH bond. Okay. And last but not least, by stating that furthermore, beryllium oxide is more stable than beryllium carbonate, let's say. Okay. Oxide is more stable than the carbonate. Okay. So that is why these are all 8 key points that you want to this one. So for the short notes later, I will share in my blog also can. I will also share in the chemistry term 2 groups. Actually, I've already shared previously in that group. So never mind, I'll reshare again so you all can view back. Okay, and if you buy my latest edition of the semester 2 books, this one, charge density decrease, increase, sorry, typing error, sorry, decrease. Yes, you are right. Thank you very much. Thank you very much. Sorry for that. I apologize for my mistake. Okay, this is correct. Charge density decrease as ionic radius increase. Yes, correct. Okay, thank you very much for reminding because I'm so sorry I made that mistake. Okay, so with that is the 8 key points that you have to write out whenever you are trying to explain the group 2 thermal stability. So if you buy my books, I've already give you the short notes, so try to benefit from it. Okay, so with that is how you solve 19C. Okay, so shall we move on to the next one? Okay. Okay, then 19D. The melting point of the group 2 oxide are given in the table below. Explain the trend of the melting point. So sometimes the STPM might ask a little bit thing off from the syllabus. So including these questions. So however, in here, I hope that it's not too difficult for you to explain why is it that the melting point decrease when going down to the group 2. Okay, so 3 marks only. Okay, 3 marks only. So try your best to explain as fully as you can. Okay, so you have to, from here you can clearly tell that it is due to the ionic size or ionic radius. Okay, so why is it that the melting point decrease? So first of all, you have to say that the melting point of the group 2 oxide decrease when going down to the group as the ionic radius increase. Okay, so as a result, the lattice energy decrease. Okay, lattice energy decrease. Hence, the electrostatic attraction forces between the cation and O2 minus also decrease. Okay, so you explain from the angle of how will it influence the lattice energy of the group 2 oxide in here. That is why it is decreasing with the melting points in here. Okay. Okay. So with that, that is for number 19, D, 3 marks only. And last but not least, number E. E is a calculation question. Dolomite is a mineral with the formula CaMgCO32. 1.00 gram of sample of dolomite produces 0.45 gram of carbon dioxide when treated with excess hydrochloric acid. Construct a balance equation for the reactions involved. What is the percentage of the purity in the dolomite of the sample? So in here, obviously, you have to make use from the angle of the carbon dioxide to calculate the purity, because only the calomite in here can react with the acid to release carbon dioxide. Okay, so that is how we are going to calculate. So first of all, you have to write a balance equation that reacts with the HCl. So CaMgCO32 plus 4HCl gives CaCl2 plus MgCl2 plus 2CO2 plus 2H2O in here. Okay. So this is the equations. Basically, it is a combination between calcium carbonate and magnesium carbonate. Okay, so you produces in form of 2 mole in here. So from the mole of the carbon dioxide, so 0.450 substitute as exactly given to you in the question. So 1.00, 0.450, all of these are trying to tell you that your final answer should also be in 2 significant figures. Okay. So 0.450 divided by 12 plus 2 times 16, so you get 0.0102 mole. So stoichiometrically, 2 CO2 is to 1 dolomite. So mole of dolomite is divided by 2, so you get 5.11 times 10 power of negative 3. Then you calculate the mass of the dolomite, okay, where mass of dolomite is equals to mole multiplied by the molar mass. So 5.11 times 10 power of negative 3. Multiplied by 184.4 gram. So this one, how do we get 184.4 gram? You have to sum up. Calcium is 40.1. Magnesium is 24.3. Please check your periodic tables for the correct part. Do not memorize value that you used to calculate, that you used to memorize in your SPM level. In your SPM level last time, magnesium is 24, isn't it? But in STPM, look at your periodic table, magnesium is 24.3, okay? Teacher, can I, instead of say using atomic radii, can I use atomic radii? No, ionic, must be strictly ionic, because this is ionic compound, so must be ionic, okay? Okay, so back to our final answer. So our final answer in here is purity is 0.94 gram divided by 1.00 gram. So you get 94.0%. Okay, in 3 significant figure. Okay, final answer is 3 significant figure. Okay. Okay, so with that, that is the calculation part of the this one. Okay, so with that, that is all for how you answer for question number 19. Okay. Okay, so any else question that you want to ask for this question? So for more information, this one you have to, in organic chemistry, when it comes to theoretical concept, you have no choice but to do short notes of your own, and then try your best to answer as much as you can. Okay. Use mole to find purity, can. Use mole to find purity also can, yes. Okay, there is also an alternative answer toward that. If you can propose in the YouTube here, can you please help them? Okay, can you please help them if you know how to solve this? At the end of the day, you still get 94.0%, isn't it? Okay, so if Nicole, if you can help them, you can also use this mole concept to help them. Okay, so please help me on that, please. Thank you very much. Yes, the answer is the same too. So can you please copy paste, screenshot, or whatsoever, help them on that. Thank you very much. Okay, so let's go back to our this one. Okay, so with that, that is for essay question number 19. Immediately we move on to the last essay question. So the last essay question is essay question number 20. State of matter 19, no need state of matter. Inorganic chemistry, not important state of matter, so don't worry, okay? Okay, last but not least, question number 20 is about group 14. So 20A sounds like this. Lead 2 chloride and lead 4 chloride has melting point 327, 498, and negative 15 degrees Celsius respectively. Describe the bonding in these three substances and explain how it's account for the above melting point. Okay, so you have to use the structure and the bondings in this case to explain why is it that they have such variations of the melting point. Okay, so lead is a metal hold by metallic bond, so it can delocalize electron from the 6s and 6p orbital. Usually it's 6p orbitals that is delocalized. Okay, supposedly 6s and 6p. Sorry for that. But 6p is more accurate for lead actually. Okay, so 1 mark for each of them. And then for lead 2 chloride, why is it 498? Because lead 2 chloride is an ionic compound hold by giant ionic crystal lattice. Okay, so that is the reason why it has a high melting point. And last but not least, why lead 4 chloride has negative 15? Because lead 4 chloride is a simple covalent molecule. Can you help me to change this one? I'm so sorry. Supposedly is simple covalent molecule. The word simple covalent must be there. Sorry for that. Simple covalent molecule hold by weak van der Waals forces. Okay, hold by weak van der Waals forces. Okay, hold by weak van der Waals forces. Okay, so that is how you answer for question number 20A. So you have to understand the bonding and the structure inside all the compounds in the group 14 as much as you can. Okay, so that is for question number 20A. Kavya, can I answer your questions later after we finish discuss this? Because now we are in the question 20 already. Okay, sorry. Okay, B, standard electrode potential at 298 Kelvin for some half cell are given below. So A, arrange the ascending order of increasing strength as reducing agent and explain your answer. So what is the this one? Okay, so Jeffrey, can I answer to you later? Sorry, we discussed this. Let's finish this first, then I settle with you. Okay, so in terms of the increasing, so the increasing now how to determine which one is also oxidizing agent, which one is reducing agent? Okay, so here is the technique. To determine oxidizing agent, to arrange from weakest to strongest, you look from the least positive or most negative to the most positive or least negative. I repeat, if you are looking for the order of increasing oxidizing strength, you look from the least negative, the most negative or least positive to the most positive or the least negative. Okay, so this is for oxidizing agent, and then you look at the species on the left. You look at the species on the left. Conversely, if you now, like this question, you are looking for the increasing strength as reducing agent, isn't it? So you look from the most negative, from the least negative or the most positive to the most negative or the least positive. After you get that arrangement, then you look at the species at the right side of the equations. Okay, so in this case, the most positive is 1.80. Then you have tin, 0.15. Then you have germanium, positive, negative 1.60. Sorry. Okay. Then you look from the species which is the right. So according to the order of increasing, reducing strength, Pb2 plus is the weakest, followed by Sn2 plus, then Ge2 plus. Okay. Okay, so then you have to explain why is it that you arrange in that order. As the more negative inert value, equilibrium shift more to left, that means more readily to be oxidized. So that is how you are going to increase in order of increasing reducing strength. Okay. Zinni asks, can replace with bracket if we confuse for more negative or more positive? You can use comma, you can use bracket. Actually, comma, bracket, sign is not important. The most important is order. So if let's say you use mathematical symbol, you write GE2 plus, then you put mathematical symbol, then SN2 plus, then you put mathematical symbol PB2 plus. But the order is wrong, isn't it? We do not accept mathematical symbol in STPM chemistry. Okay, we do not accept STPM mathematical symbol in STPM. If the order is correct, then it's correct. If the order is wrong, then it is wrong. It has nothing to do with any chemical symbols, mathematical symbols, any symbols that you use. No matter you use comma, you use space, you use bracket, or you use whatsoever, it doesn't matter. The most matter is the order. Okay. Okay, so that is for B1. And last but not least, B2, based on the value above, explain the stability of +2 and +4 oxidation state for the ion stated. Okay, so in here, you write stability of the +2 oxidation state increase from GE2 plus to SN2 plus to PB2 plus. And then I will also usually advise students to write the stability of the +4 oxidation state decrease from PB 4 plus, SN4 plus, GE4 plus. Okay, so you write both of them. This is not contradicting because it is in the correct way. It's just that you use different angle to explain. Okay, so it is okay if you do that. Okay, so then you explain why. Because inert value is increasingly positive. Okay, so when equilibrium inert value is increasingly positive, so equilibrium favor more to the right. Okay, so therefore PV4 plus is the strongest oxidizing agent. So since all group 14 has the valence electron of NS2 and NP2 due to the increasing inert pair effect, so therefore 6s electrons are harder to remove or easier to remove electron from the 6p orbital. Also can either way. Okay, so whenever you are trying to explain the stability of the +2 and +4, I will always recommend students to write these first two statements. If you buy my short note, if you buy my new books, the short note is also there. You must have all group 14 has two oxidation state, which is +2 and +4. So then +2 oxidation state stability increase when going down to the group 14, and then you say +4 oxidation state stability decrease when going down group 14. So that is always the statement that you must always write whenever you are trying to discuss the +2 and +4. Only then you finally explain why is it lead is more stable as a +2 oxidation state due to the inert pair effect. Okay, so electron from the 6p, 2 electron from the 6p is easier to remove compared to excitation from the 6s to 6p and etc. Okay. Okay. So I guess that is all for the discussion of the essay question. And I hope that you all benefit from the questions that I've purposely set for you for today. Okay. Even if I said that is a trial for my school exam, actually that is not really a trial. So I've set another set of paper in the trial, and I'll share in my blog 2 weeks later. So don't worry about that. Okay. Okay. So okay. Any questions that you want to ask? So now is your free time to ask any questions. So if you have any question, feel free to ask. Sorry. Okay, so let's ask. Okay, so teacher, may I know both term metalloid and semi-metals are accepted or not? No, cannot. Metalloid is metalloid, not semi-metal. So inert pair effect is used for what? Inert pair effect is used to explain the why is it that the plus 2 oxidation state stability increase when going down to the group. This is especially applied for for lead. So if you want more information, please refer to my notes or go to the YouTube. I've already explained in details. Okay, sir, just now you said cannot use positive negative values, should use exothermic, endothermic. No, the earlier person asked just now, teacher, can use negative VE, positive VE or not? Cannot. Must use full word, endothermic, exothermic. Okay? So cannot use symbol, must use word. This is essay, so you must use word. Okay? Cannot use negative VE, positive VE. That is what that question trying to ask just now. Teacher, may I ask if question 16, the equation at not still remain the same if I what you written in the textbook, since the fuel cell used acidic, so the equation did not change. No. Acidic fuel cell and alkaline fuel cell are two different. I'm so sorry I did not update my books. Did I not update my books? I think I do You use the old version one, is it? The latest version I've already updated that they got acidic and alkaline fuel cell. Okay, so I'm so sorry if you look at the old version one. Okay. So how to join the group that you mentioned just now? Just search for chemistry term 2. Chemistry term 2. Okay. Didn't know you famous like this. Okay, I would like to ask tin stable in +4 or +2 since the inert value is positive. Okay, tin is a very selective element. There is no guarantee that says that tin is more stable as +4 or more stable as +2. It depends on what compound. If you are asking oxide, tin is more stable, oxide, tin is more stable as SNO2 instead of SNO. Okay, so tin is more stable as a +4. Tin oxide is more stable as +4. But if chloride, tin chloride, so tin chloride is more stable as +2. So SnCl2 is more stable. So that's why I said there is a there's a silver lining inside this tin. You cannot guarantee says that. But in terms of the inert value, definitely SN2 plus is more stable since the inert value is positive. Okay. So that is the best answer that I can give to you. PB4 plus is an oxidizing agent. Yes. PB4 plus is oxidizing agent. Okay. Inert gas or noble gas? No lah. Okay. Inert. Noble gas is guaranteed an inert gas, but not all inert gas are noble gas. Okay. For 2B2, why no need to state the stability? Because the straight question asks about reducing agent. So when they ask about reducing agent, you are going for oxidation. Okay, so that is the reason why. Hello, sir. How does covalency compound contribute to them of being amphoteric? For example, Al2O3 and BO2. Okay, for Al2O3 and BO, you have to mention this statement. So why these are the different. Okay, for example, if the question asks, explain the M4. The question sounds like this. Okay. What is an amphoteric oxide? An amphoteric oxide is an oxide that can react with acid as well as a base. Why is it aluminium and beryllium oxide are amphoteric? Why? Okay, then you answer as this is because aluminium oxide and beryllium oxide are ionic compound with high covalent characteristic. Since aluminium and beryllium ion has a high charge and small ionic radius. Okay, so that is the way lah. Okay, so how do we know Hess cycle should be reversed or not? For the application of the Hess cycle in here, you can see from in my YouTube, I explain a lot of example, isn't it? So why don't you go to the example and you see on how I draw the Hess cycle inside that? Okay, so you can see from them. Teacher use symbol, both are accepted unless the question said name. If SnCl2 is unstable compared to SnCl2 is more stable. What point should I mention when explain amphoteric properties? Amphoteric properties depend on what you want to explain. Most of the time, amphoteric properties is going to for group 14, isn't it? So for group 14, then you must mention that all group 14 has +2 and +4 oxidation state with the MO and MO2 formula. Then you say that then you describe all the COSIO is neutral, GO, PBO, SNO are amphoteric, then write the equation. And then the CO2, SiO2 acidic, write equation. GO2, SNO2, PBO2, amphoteric, write equation. And then if explain why is it amphoteric, either they are ionic compound with high covalent characteristic or covalent compound with high ionic characteristic. Okay. Okay, sir, can electronic configuration or element write using noble gas configuration? Cannot. When write full, must be write full. Okay. 1s2, 2s2, 2p6, 3s2, 3p6, for example. You must write in full. Okay. Valence electron is valence electron. Okay, thank you very much. Thank you. Welcome. Wait, sorry. Why metalloid different from semi-metal? Metalloid is metalloid. Where do you learn the term semi-metal? There's no such thing as semi-metal. So may I know CuNH342+ is formed instead of CuNH36? Ammonia is 4. Don't ask me why like that. Don't ask me. I don't know. So what is the best way to explain conductivity? Okay, I think you are referring to group 14's conductivity, isn't it? Okay, if you want to explain conductivity, let's say if you're comparing between metal and metal, you use the number of valence electron, then greater the number of valence electron, greater the number of electron delocalized. If you are comparing between metalloid, and non-metal, so you said you use the band gaps theory, where in conduction band and valence bands are overlapping each other. Then semiconductor, there is a small gap between conduction band and valence band. And then if it is a insulator, there is a large gap between conduction band and also valence band. Okay. Okay. Descending the group, does electrical conductivity metal increase or decrease? For main group metal, group 1, group 2, electrical conductivity increase. From your book, I saw alkali first cell but not acidic. Which is it new version? My latest version is version number 4, 4th edition. Okay, 4th edition. So let's say question suggests a reason. Can we suggest more than one reason? If correct, no problem. When do I need to talk about interionic distance? Lattice energy. Aluminum chloride exists as dimer in standard condition when it's heated, decomposed to become Al2CO3 or Al2. Okay, things is like this. Under room temperature pressure, aluminum chloride exists as Al2Cl6. When heated, it's sublimed to become Al2Cl6 gas. Then it heated strongly, then it will break to become AlCl3. Okay. Dilute acid alkali, concentrated acid alkali liquid, is it correct? The state. Concentrated or dilute, it doesn't really matter. Okay, unless you only need to state when it is a. I assume that you are referring to the inorganic chemistry reactions. The only place that we need to stress on the concentrated is for silicon oxide. Silicon dioxide, you have to use hot concentrated alkali. And then if you are discussing about group 14 oxide, especially lead-4 oxide, because lead-4 oxide, if you react with concentrated HCl and dilute HCl, they have a different reactions. So for more information, you might want to refer to the notes, okay, or to my YouTube video also can. Okay. Answer already, cannot. If question state relationship 1 mark, can we just write the equation? Cannot. Relationship 1 mark, then state the relationship. Why use equation? How to explain electrical conductivity down group 2? Electrical conductivity going down group 2 increase. E0 value increase. Okay, what else? Okay, for the reaction of the oxide of group 2 or group 14 element, is that insist to write state of matter? No, not insist. State of matter is only important in thermochemistry and the standard hydrogen electrode. And then if the question gives you state of matter, your answer must also include state of matter if write balance equation. Okay. How to relate oxidizing and reducing agent to explain the corrosion? Example. What is the anomaly for silver halide? Huh? Silver halide got anomaly? I don't know. Sorry, out from my knowledge. Normally, we know that HCl, NaCl is soluble. If question shows that enthalpy change of solution is endothermic, if you follow my books, already highlighted that even though enthalpy change of solution is endothermic, sodium ion, potassium ion, and ammonium ion is still soluble in water. Oxidation of iodine H2SO4 has 2 equations. Which one should I write? Oxidation of iodine with H2SO4 only have 1 equation, which is 8Hi plus H2SO4 give 4I2 plus H2S plus 4H2O. That is the only equation. Standard electrode potential and standard reduction potential same. Yes. Okay. Any else question? Okay. So I guess I don't see any more questions. I think I have already answered most of your questions down here. Okay. So I guess with that, that is all for our session sharing for today. To those who missed this session, you can view back on the YouTube. It is automatically recorded on the YouTube. Where can I buy the books? You search for Shopee. Shopee, then you type STPM Chemistry. You probably see my books. Okay. Okay, thank you for teaching. Okay, thank you. Okay, welcome. Okay, so I guess that is all for our talks today. So good luck and all the best to you, STPM 2021 semester 2 examination, which is next month. I wish you all the best, and I'll see you all in the next talk for semester 1 and semester 3. Okay. So if you haven't buy my books, you can always buy from Shopee, and I will see you around. Okay. Okay. So thank you very much for listening to my talk today. I apologize for any inconvenience caused. If I give you any typing error, please apologize. I'm also a human. I make errors. Human is I also make my mistake. Sometimes all I try to do is doing my best to help all of you as much as I can. Okay. Okay. So I guess that is all for my just sharing session today. So that's all for our lesson today. Okay, so happy. Thank you very much. Bye-bye. Bye-bye. Okay. Okay, so I close already. Okay, bye.